Very good morning. Today we are going to see about an introduction to database management system. Yeah. So as everyone knows, what how what is the importance of data in real life? Yeah. Wherever we go, the data is very important. Even about mm, what a public, or if you're a student, or if an employee, yeah, your information, your data has to be stored. Yeah. So we know the importance of the data, what data is. So today we are going to see what is database management system, what data, what is information, yeah, and so on. So these are all the some of the important topic which you are going to see today as a part of an introduction. Yes. So the very first topic is data. What is data? Yeah. Yes, Kabul. See, in simple, what I can tell you is data is a stored facts, a raw facts. Yeah. So, for example, as a students, you are all here. Yeah. As a student, if you're maintaining a student record, you would like to have some information, some details about the student. Okay. Yeah. So, say, let me pinpoint, let me narrow down my topic towards a good example. Yeah. See, what I can tell you is here to have some information about the marks that has been stored by student in different subjects. Say, listen here. I mean, the physics, okay, and chemistry, math. So here I've written the three subjects. Yeah, the physics, chemistry, and math. Okay. So I want to have some information. I mean, these are all the different subjects a student would have undergone. All right. Yes. So this is one data. Okay. It is a stored. So this is how we can store it. Simply I can store the data. Yes. And the marks scored by a student in subject physics, maybe 98 or 97 and 100 in mathematics. Okay. So this is another data. So these data can be stored in the database. So this is the fact about the student. Okay, the real marks that he has scored, that I'll tell you. Yeah. So this is separately stored, and this also will be separated. I mean, it will be stored separately. For this reason, we can call these two data individually as a stored facts, or we can say it is a raw facts. Yeah. And this data may be of any type, as mentioned in the slide. Data may be a numerical data which may have integers or floating point. So these are all the integers, 98, 97. If it is 97.5, as we know, it is a float point. All right. And non-numerical data such as the characters, date of birth, and so on. So here the subject name, physics, chemistry, and math. And these are all the character data. The type of data that can be stored. Yeah. So say, let me pinpoint, let me narrow down my topic towards a good example. Yeah. See, what I can tell you is here is you would like to have some information about the marks that has been stored by student in different subjects. Say, listen here. I mean, the physics, okay, and chemistry, math. So here I've written the three subjects. Yeah, the physics, chemistry, and math. Okay. So I want to have some information. I mean, these are all the different subjects a student would have undergone. All right. Yes. So this is one data. Okay. It is a stored. So this is how we can store it. Simply I can store the data. Yes. And the marks scored by a student in subject physics, maybe 98 or 97 and 100 in mathematics. Okay. So this is another data. So these data can be stored in the database. So this is the fact about the student. Okay, the real marks that he has scored, That I'll tell you. Yeah. So this is separately stored, and this also will be separated. I mean, it will be stored separately. For this reason, we can call these two data individually as a stored facts, or we can say it is a raw facts. Yeah. And this data may be of any type. As I mentioned in the slide, data may be a numerical data which may have integers or floating point. So these are all the integers: 98, 97. If it is 97.5, as we know, it is a float point. Alright. And non-numerical data such as the characters, date of birth, and so on. So here the subject name: physics, chemistry, and math. And these are all the character data. The type of data that can be stored. Yeah. So here is an example. As I told you, the physics, chemistry, math, and biology. And here we have an example. I mean the marks, the 98 marks, 89, 87, and 92. Yeah. These are all some example for the data. So next, what is information? So we have a data here. Yes. So data here is the different subjects. Okay. Yeah. And the different marks. Different marks. Yeah. So what is information here? What information means? Out of the stored data, what are we going to understand? Yeah. See here, physics, chemistry, and maths, and here 98, 97, 98. What is this? What are they? What is this? These are subjects. These are marks. As we know, yeah, how the system it knows, and how is it possible to understand for a layman, for how the common man can understand? Yeah. So if this mark and the subject are being rated, and it has to be related properly. Physics, the mark of the physics should be marked with the subject physics, and the mark scored by the student in chemistry, that has to be mapped, that has to be related, and that is what we call as the related data. Now look at the definition. Information is a related data which is used by an organization, a college, a library, a bank management, a manufacturing industry, whatever the application that you go for. That relation is very, very important. Only if these two data, so this is data 1 and this is data 2, only if these two data are being related, then we'll get some information. We'll get to know this so and so mark has been scored in the subject physics by so and so student, and this mark has been scored in chemistry by so and so subject. So only if there is a relation. If there is no relation, no information. So for that reason we can call information as a related data. That relation is very, very important. Yes, good. Next, we're going to see about what is database. Yeah. So already I've given you an example here and on the slide as well. Yeah. So we are showing the details about the subjects and the marks scored by a student, by one student. Alright. You'd like to store information for different students, the number of students that you have in your class, in your section. Yeah. That is what we call as we need a strong base over which we can store the information of student 1 and student 2 and student 3, like a pile of records. Yeah, the pile of data that can be stored, and the provision provided for this purpose is what we call as database. Right. Yeah. So now we have stored the information. The information are being stored here. Yeah. Yes. And how the stored data can be retrieved back, and how it can be accessed. Yes. Say for example, so instead of the actual score scored by the student is 100, but it has been wrongly entered as 98. Yeah, it is a wrong information. Instead of storing 100, I stored as 98. Okay. Yeah. And this information and this data has to be updated, and how it can be done. Yes. And this 100 has to be replaced. If you don't want any one of the records, say like you don't consider a subject mark, a subject math, you don't want the math marks, and that data has to be removed. How it can be done? Yes. And this process is what we call as the managing how efficiently this data, the stored data, can be managed, and that is what we call as management. How it can be done? Yes, in order to manage the stored data on the base that has been provided, yeah, we write a set of program, a set of instructions to access the data, instructions to update the stored information, instruction to delete a data, and that is what we call as the system. In toto, we call database management system. It is a collection of interrelated data for accessing, for inserting, and for deleting records from the database. And that is what we call a database management system. Look here, the definition which I've told you: a collection of programs that enables you to store, that we're storing here, modifying, making changes, and extracting information, accessing the stored information from the database. And that is the literal definition of database management system. Hope you understood the definition of database management system. Yeah, fine. So next we'll see the database applications. The applications of database. As we know, wherever we go in this the recent society, we have the banking system, the airline management, ticket reservation, online reservation, manufacturing, cinema ticket booking, and everything. So these are all some kind of the real-time applications that we go for. That is a part and parcel of our life now. Good. So next, the important topic that we are going to see about the difference between database system and the file system, the traditional way of file system. In olden days, what we have been doing for maintaining a record, a student record, so we'll collect the hard copies of the mark sheets or the rank cards or the scorecards of an individual student that will be separately collected, or in some cases it will be taken a printout, it will be printed out, and it will be filed in a normal tag files. So that is the normal traditional way of maintaining record. That is the normal database system. The files, that is what we call as a file system. Yes. What are all the problems that we may face in file system? The first and foremost problem is redundancy. What is redundancy? See, I have stored the detail or the information of one student, okay, the roll number 1, or say for example roll number 1 or anything. Yeah, so wherever the human we are working, we have the possibility of having an human errors. Yeah, unknowingly I can file the same information which I've already filed about one student. Say the roll number 10 has been filed twice. As we are discussing about the file system, yeah, the second problem that we may face here is difficulty in accessing data. Yeah, in normal traditional file system, if it is the sizes of larger size, I mean the files of larger size, it is very hectic for us to identify one particular information about one particular student. That is what the difficulty that we may face in traditional file system in accessing data. All right, and data isolation, we may have to be maintaining multiple files, and different formats would have been followed, that has been maintained. So these are all some kind of the physical difficulties that we may face, and also the integrity problem as well. And who is responsible, who is accountable in maintaining that file? If one information, if one data or one student information would have been lost, and who is responsible, who is accountable for this? Yeah, and like this, these are all some problems that we may face. And apart from that, the atomicity in updates. Yeah, say kind of some drawbacks of using file system is that updation is not possible. Yeah, that entire file, entire record has to be removed, and it has to be unpacked, it has to be dismantled, and the new updated information has to be inserted in the exact location again, it has to be mantled again. So these are all some problems that we may face. The concurrent accessing of multiple user, that is not possible. Yeah, the security problems, as I told you, the integrity problem, who is accountable for that, for data loss. So these are all some real-time problems, the difficulties that we may face in physical system. So these problems can be addressed. An exact solution that can be found in the database management system. The accessing is very easy, redundancy can be avoided, yeah, and the integrity problems can also be avoided, updation, insertion, everything is very simple here. That, good. Next we are going to see about the data abstraction. What is data abstraction? Means we have stored the data here. So what levels, what views can be given? So what level of data or the information can be abstracted from the stored data? So we have three levels here: the physical level, logical level, and view level. In physical level, we just simply describe how a record is stored, how a student record is stored. Only that level of information will be provided for a common man or anyone. That is called physical level. And second, logical level. So here it describes the data stored in database and the relationships among the data. Yeah, as we have discussed already about the data. Yeah, here the subjects are here and the marks data 1 and data 2. So these two things should be related properly. Only then it is easy for us to understand. And this is the so and so marks scored by in the so and so subject by so and so student. That relation, only if they are related, we call that as an information. And that is what we call as the logical abstraction. And third type is view level. So what is that view level? The application programs hide the details of data types. Yeah. See here, the data 1 is there and data 2 is also here. Yeah. The data type of the subject is physics. I mean, for the subject is physics, chemistry, and maths. What is the data type? So it is character data. CHAR. Character data. Okay. And the marks that we store here, what is the data type here? Yes, marks, number. Yes, number or numeric is the data type that can be assigned for all the numerical integer values here in database. Yes, this is what we call as the view level. The application program hides this data. This data types will be hidden. It will not be made available for a layman, for a common man. These are the three levels of abstraction. And this has been shown diagrammatically, an architecture of database management system, a view level, logical level, or physical level. So these are some different the levels of abstraction, the view levels for the user, according to the type of user can be provided. Right. Huh. Good. The next topic that we are going to see now is instances and schema. What is schema? Before we go for instance, let me explain what is schema here. Yeah. So the schema, see, it is a plan. What sort of information, what sort of data I'm going to get from the student? Okay, I'm going to create a student database. So what sort of data that has to be retrieved from the student? That has to be planned. That has to be decided, and that is what that how it can be decided. Say, I'm going to get only the information, the student ID, okay, and his name, and the mark scored in different subjects. Okay, yeah. So these are the three information, the three detail that I'm going to get from the student. Yeah, and this should be described in this format, and this is what we call as schema as. Yeah, a schema, the database consists of information about a set of customers and account. Here for this example, it keeps differing. So here I have taken an example for student database, where in the slide I have given the example for customer and account management or anything. So it has to be properly related. That schema itself, it should explain the relationships. That is very important. Okay, the physical schema and logical schema. Yeah, as we have seen the physical level and the logical level, the abstractions. So that is what we mean here as. And next we are going to say about instance. What is instance? Yeah, so I have student ID 1 2, and name is A, B, and C, and mark is 50 and 70 or anything. All right. So at this point, what is the information of, what is the status of this student database? And that is what we call as instance, the actual content of the database at a particular point of time. And that is what we mean as instance. In the forthcoming slides, we'll have another example for these instances. Yeah. So next topic that we are going to see is the next topic that you're going to see is the physical data independence. What is physical data independence? The ability to modify the physical schema without changing the logical schema. Let me explain how. Yeah, we have already have stored. We have got the logical schema. So this is a logical schema for a student database. Okay. So anyways, this is going to be stored in a physical location. I mean, the database. So it is going to be stored in a physical location. So we call as a DB1, database 1. And likely I can have n number of databases. Yes, the DB2 and DB3 and so on. I can have n number, right? So what we say as a data independence, that to a physical data independence is, yeah, so the schema will be the same. Instead of storing in database 1, I can change the location, and this same schema can be stored in database 2 without modifying the logical schema, and this is called physical data independence. The ability to modify the physical schema without changing the logical schema. So that is what, because any application will always depend on the logical schema that we take. That is very, very important. So that is what as mentioned in the slide. The interfaces between the various levels and the components should be well defined so that the changes in some parts do not seriously influence the others. I am changing the location here. Yes, in spite of changing this location, it should not affect the logical structure. That is what the physical data independence. Yeah, hope you understand. Here, as I told you already, here we have some examples for the schema. So it's a schema of an employee table. Yeah. So here we can have instead of for this here in this example the student ID, student name, and marks. And likely we have here this employee number, employee name, salary, and address, and the department and project. And this is the instance of a database at one particular point. What is the content of the database? That is what we call as instance, and here you have an example here, right? So this is the diagrammatic representation. Yeah, the external schema, the conceptual mapping, and internal physical level schema. The three levels of abstractions that we have seen. That is what it has been represented in another way. Good. Data independence. We have the two types of data independence. One is the logical data independence, and another one is physical data independence. The second one, the physical data independence, which I have addressed already. Yeah, though there is a change in the physical location where I'm storing the database, it should not reflect in the logical schema. This is called physical data independence. The vice versa is what we can call as a logical data independence. Yeah. So these are the two types of data independences that we can have here. Right. Fine. So far we have seen about what is data, what is information, what is database management system, what are different levels of abstraction. Yes. So these are all things that we have seen, and types of data independence, so on. The very important topic that we are going to discuss now is the language. Yeah, what is language here, and what are the types of language? Yeah, see, for a real-time analogy, what I can tell you is, say, I'm just I want some things to be done by students. I want certain things to be completed. Certain homeworks should be completed by the students. So what I'll do, I just instruct them. How will I instruct? The way the students can understand. So here, the communication plays a vital role here. So how I'm communicating? So through my language, yeah, what language I'm following. So English is the medium of language, or we call as a medium of communication. Through English, I'm instructing my students what they have to do. Likely, you can apply this same analogy for DBMS. You want the database management system to do something for you. So how it can be communicated? We need a language. And that language is what we call as SQL, a sequential query language. In olden days, we call as a sequential query language. In industry, they call as an SQL. And other ways, we can call as an SQL, a structured query language. And we have the certain types of SQL languages that can be followed here. Some types of languages, it can be broadly classified in two ways. One is DDL and second one is DML, data definition language. And this data definition language has two subdivisions, the SDL and VDL. Yeah, that I'll tell you in the next slide. We'll go to see that. Yes. So what is DDL? So how efficiently and how effectively you are defining the data. Yes, like what type of data and what is the data type and what is its size, and everything should be defined previously. Yeah, as we have seen the schema already here. Student ID, so what is the data type and what is the data size, and student name, what is the data type and what is the data size. And this is what that defining the data. For this we need a language. Yeah, so that can be used by the database administrators. Yeah, so that is what the first slide it mentions, used by database administrators and the database designers as well. Yeah, in some DBMS we'll have a separate storage language, that is what we call as SDL, and separate view definitions. We'll have that language is called view definition language. But in recent trend, the combination of this SDL and VDL is what we call as a structured query language or SQL. Yeah, this is the latest addressing language for every common database administrators. Okay, and we have some kind of the commands that can be followed to defining our definitions. And second type is what we want to say about data manipulation language. What is manipulation? As I've told you already, yeah, I've got the student's information. Instead of one mark, instead of the mark secured by the student, I've entered some other mark. It has to be updated. Okay, and some unwanted information from the student database has to be removed. So some necessary information has to be inserted back again into the database, and this insertion and this updation and this deletion all together is what we call as the manipulation. We are manipulating the data that has been stored. For this reason we need a language, and that language is what we call as data manipulation language. And certain commands that will be defined in every DML languages depending upon the language which we work for, and the same DML can be embedded in some kind of a programming language. That is what in the second point I've mentioned as a COBOL, C or C++ or anything. Yeah, good. Okay, that's all about the DML, I mean the DDL. And the two subdivisions that we have in DML is the procedural language and non-procedural language. Yes, so the procedural language, what we do is the user specifies what data is required. Yes, so that is procedural, what data is required and how to get those data. So this will be defined very clearly. So that is what we call procedural language. In non-procedural language, user specifies what data is required and without specifying how those data can be achieved. That is the main difference between the procedural and non-procedural. In both the cases, user is going to specify what data is required. In procedural, How it can be achieved will be mentioned. In non-procedural, it will not. That makes the difference between the procedural and the non-procedural language. So this SQL is most widely used query language. Only with these two types of languages, I mean the DDL and DML, it is possible for any database administrator to manipulate, to create data and databases. Okay, thank you students. We'll see the next the data models in the next session. Thank you.